to node C. And we said last time that the resistance Rn, looking into the amplifier from the base, if this is Rs, is going to see R pi for Q1. يعني if this is a Q1, we're going to see R pi 1. This is the Rn that we will see, R pi 1, plus beta for the transistor plus 1 times Rs. So this is the rule for the resistance that we typically see, and this holds when Ro, okay, tends to infinity. يعني لما lambda is equal to 0. And then in the resistor sheet, we saw that when Ro is not infinite, because it's going to somehow connect all the way up to node C, the emitter and the collector, then the equation becomes a little bit more involved, and the equation becomes Ro plus Rc, which is all the resistance that is at the collector node. Okay, so it becomes, one second. So this is Rn, sorry. يلا حننزل على BJT. So there's a rule for the BJT, and this rule for the BJT, okay, looking into the base with the emitter connected to a resistance, and for whatever RC that we find here, the rule says that R is equal to R pi plus beta plus 1 times Rs, or if there is early effect, it becomes more involved. So it is R pi plus beta plus 1 Rs times this big factor here, اللي هو Ro plus Rc over beta plus 1, okay, over Ro plus Rc plus Rs. يعني if there was in this scenario that we show here, if there was Ro, what would be the equation? شو بتكون الإيكويشن؟ So for this same circuit that we have here, if lambda is different from 0, I will see Rn is equal to R pi plus beta plus 1 times Rs, and all of this is multiplied by some function of Ro, Rc, and Rs. What is Rc for this circuit example here? شو هي ال RC للcircuit in blue؟ RC for the circuit in blue in this circuit.
RL.
It's RL, exactly. So if I had another circuit that fed from this output node another BJT that is connected to ground, okay, what would be the effective RC then?
RL parallel to R pi.
Exactly. So I want to see the Rn that is looking into the next stage as well. لأنه at node C, all the resistance that is external to my transistor هي RL, and looking into the base with the emitter grounded. So بتصير ساعتها RL parallel to R pi هي ال RC, and we plug it into the equation. يعني I search for RC and I plug its value. I know my RS, I know my RO, so this would be RO1. ساعتها إذا هيدا هو Q2 هيدا بتصير RL parallel to R pi 2, and this is R pi 1. Anybody has a question about this little example? Is it clear? It's very important for us to be comfortable with the يعني little thing. يعني these little things are very important. Okay. So لكينا at any node, according to this rule here that we have here on this sheet, at any node, I'm going to look at the effective resistance at that specific node, which is extrinsic to my circuit. يعني RC هو كل شيء C بتشوفه براتا transistor، و RS is everything that E sees outside the transistor. Why? Because my transistor, I have already compensated for its RO and R pi in my equation, and I am assuming that if this is my transistor with its model, okay, anything that connects to it externally now at C, هيدا حيكون RC, و anything that connects to it at E, هيدا حيكون RE. يعني برات الباي موديل اللي لإلي, so I do not consider any, I just look outside and see what is the effective RC, and I look outside and see what is the effective RE or RS. Okay, طيب, great. هلا, let's go back to the slides, and in the slides we will revisit what we saw last time. So here we said last time that sorry, pardon me, but computer is refreshing. Sorry, 1 second. Oh wow, okay. The computer is coming back. Okay. Yeah, that was 1 minute. Let's see what is going on. Okay. Okay, let me just stop sharing if I can. 1 second. Now the computer is a little bit frozen. Okay. Okay, I'll try to share from my iPad. 1 second. Okay. Okay. Okay, so we are in part 3. Okay. Yeah, no, 1 second. If it doesn't work, I'll just sketch it on the notability. Don't worry. 1 second. Okay. Yeah. Okay, great. Type. Yeah. Okay, so in here we have the BJT circuit. Okay, and in the BJT circuit, we derived the gain and the input resistance by setting what Vn is last time, its function of In, and we said that Vn is R pi In, وطلعنا relation لهيدا الريزستور value. Okay, so طلعت معنا rule يلي هي we can use it from now on, which is R pi into beta plus 1 times Rs. Okay, so then we said, well, let me find the gain. We found that VO is really minus GM V pi times RL و V pi نعرفها إن هي R pi times IN, and we also were able to define Vn as function of In يلي هي it is basically V pi over R pi يعني V pi sorry Vn is V pi plus the current that is flowing in this resistor times Rs, and so we found a result that is similar to the MOSFET result يلي هي GMRL على 1 plus GM over alpha times RS. يعني if you recall when we had the MOSFET we said when we have a resistance at the source قلنا إنه الgain is whatever resistance RC I have here, and the gain is equal to minus GM RC parallel RO على 1 plus GM RS. The same equation holds in the BJT except that the GM in the denominator هذه فيها تصير RL prime لما يصير عندي RO gets divided by alpha because of the difference بين الكرنت اللي قاطع هون يلي هو depends on IC and the current which flows in RS which is IE, and we all know that IC over IE is equal to alpha which is equal to beta over beta plus 1. So this leads to a slight difference in the equation for the BJT. Okay, so if we look at the resistor sheet, if we look at the voltage gain sheet, what the voltage gain sheet is going to tell us is that if I have a BJT, okay, so in the voltage sheet, what it tells me is that if I have a BJT, okay, with a resistor RD, okay, and I have connected at the emitter a resistor RS, okay, the gain from the base to this node here, the gain from the base to this node here is equal to in total minus GMRD over 1 plus GM over alpha times RS. Okay, and so this is the equation. هلا للBJT the equation which we have in the sheet does not include RO. We do not derive it in the presence of RO. يعني بالvoltage gain sheet ما بنشتغل مثل MOSFET. بس للMOSFET we gave you a complex equation where RO exists. For the BJT we said the equation in the absence of RO is minus GM RO على 1 plus GM over alpha RS. Okay, where alpha is equal to beta over beta plus 1. فإذا أنا I will find the gain from this point to this point, and it will be function of GM, function of R load which is RD in this case, and اللي هو resistance seen at the node C, and function of RS. Okay, is the equation clear to you all? So لكن هلا what we can do is we can continue to look at the next slide. So in the next slide they ask me to find the output resistance of the amplifier. So to look at the output resistance of the BJT, really this is the BJT. I have here RS at the emitter node, and I have here Vn, and he's asking me, of course I had R load, but what do we do when we are studying R out? We look in the eyes of R load, so we really erase it, we remove it, okay, and we set Vn to be equal to 0 when I find RO. Okay, so this means that I am looking from this here, okay, and I have set Vn which was connected to the base node to 0. Now this is very similar to the MOSFET case. Why? Because I can draw the circuit like this. I can draw this current source, okay, I can draw in parallel to it RO. This is GM times V pi. Okay, and this here at this node, if I want to look at this resistor and this resistor, really I'm looking at RO between this node and the ground, right? But this node, ground is really now node B. And so between B and E, I have R pi, right? And also this node is ground, so it is also B. And between B and E, I have RS, so this is R pi parallel to RS. And this is plus minus V pi. Okay, so now what I am looking at is I have on one side R pi parallel to RS. Okay, I have on another side a current that depends on V pi, and I have, and this is node C, and I have a resistor parallel to this current source, which is RY. So this is a branch Y, and this is a branch X, and this is GMVX. صار أنا عندي RX هو R pi parallel to RS, and RY is equal to RO. Okay, يعني the resistance seen is going to be RXY, which is إذا هيدا سميناه RPS for the simplicity, is equal to RX plus RY plus GM ضرب RX ضرب RY. Okay, فإذا looking down the collector of the BJT with the base node grounded and a resistor RS at the emitter, we are going to see RXY. So if this is transistor Q1, it is going to be RX اللي له هو R pi 1 parallel ل RS, will RO هو RO1, will GM1 times RPS times RO. Okay, so this is very similar to the MOSFET case. Okay, مثل الموسفت لما كان الموسفت عنده هون a resistor RS, we were looking down and we have grounded this. We saw again RXY, but the only difference هونيك إنه we did not have is that we did not have what? We did not have the R pi. Okay, so هون ال R pi لأنه we grounded B, it fell down to be in parallel to RS. Anybody has any questions? حدا عنده سؤال on this slide? Is it clear?
Yes, clear.
Okay, thank
Doctor, all
you.
good.
Thanks. Okay, so head derivation لألا here, and we're not going to go through it. And then we will look here now at, so this is the common emitter with emitter resistance. هلا we're going to look at another circuit, which is the common gate amplifier. هلا each amplifier has a function. Common emitter with emitter resistance, the gain is smaller. In the case of the BJT, the input resistance is higher, and later we will learn that it helps stability. The common gate amplifier, since they said the gate is the common node, it is going to be DC. يعني in the small signal analysis, it's going to be grounded. Okay, so the output is going to be at the drain, and the input is going to be from the source node. Okay, يعني I'm going to lump V sig R sig and plug them in to the source node. So the previous stage is feeding my source node. Our objective is again to find the gain, the input resistance, and the output resistance. Okay, طيب great. Let us try هيك to guess just for the fun of it, assuming that this is ideal, يعني it's R tends to infinity. What is the output resistance of this circuit? بدي شيل ال RL وبدي حط هيدي DC لأنها في bias, and I'm going to study the output. What do? I set Vin to 0, right? So هيدي ال VN على end of R sig يعني هو كلهم راحوا صاروا shorted. So what is RO? And let me بس لأنه هلأ بدنا نفرق بين RO و R out later بس I'm just starting with whatever you remember now. What is RO for this circuit? بعدين نرجع نلحق السلايدات. So it is looking into a MOSFET whose source node is grounded, right? And whose gate is also grounded. What do I see? هيدا عم تطلع هيك على ترانزستور. صح. هيدول grounded صح؟ So I'm going to see the little RO. Okay, so I see the little RO. طيب هلا let me ask you this question, which is if I now have a capacitor and I'm doing small signal analysis, and let us say that this is equivalent effective resistance is equal to RO, or let us say RO2, and this has resistance RO1, and I have a capacitor here connected to the load. Okay, and I want to find the resistance seen by the capacitor by OCTC. What do I do? In small signal analysis, أول شيء هي ground وهي ground. Okay, and what do I do with VSIG? What do I do with VSIG in the OCTC? I set all the signals zero. So راح هيدا صار shorted. So what is the resistance seen by C? هبعت current. Where is the current going to flow? Into RL. This current source gets replaced by its effective resistance. صح؟ لأنه أنا بشيل ال DC current source بخلي له effective resistance اللي هو RO2. So أنا if I'm sending a current, it's going to flow up into RO2, down into RO1, and down looking into what? Down looking into the drain of the transistor whose gate is grounded. Okay, and at the source node, what do I have? شو عندي على source node?
We have RS.
RS. Do we know this equation? What is this? It's RXY يلي هي معمولة ال RX اللي لها من RO RS وبتعتمد على GM, right? RO1 plus RS plus GM1 RS RO1, right? So this is going to be equal to RO1 plus RS plus GM1 times RO1 times RS. Okay, so this is the effective resistance seen for the MOSFET. يعني RC حيكون بيساوي RO2 in parallel with RO1 plus RS plus GM1 times RO1 RS in parallel with what? RL. You see the difference now? If each one will see what's outside it and how things will act differently. Anybody has a question about this problem? طيب هلا for our purposes if nobody has a question, sorry, لا, let me go back. For our purposes, okay, so for our purposes, let us go back to this slide. We are going to define, okay, we are going to define two things. واحدة اسمها R out, واحدة اسمها RO, okay. So R out is what? Sorry, R out is what? R out is the resistance seen looking into the إذا أنا عندي common source amplifier where sorry, common gate amplifier, okay, with some signal, okay, and I'm looking into it using RO. اتفقنا إنه أنا I'm going to short everything up to node Vn. Okay, so I'm going to short up to node Vn. If we define something called R out, okay, so we are going to define something called R out, and this R out is أنا كان عندي قبل VSIG and RSIG, okay. R out is when VSIG is set to 0, so I am going to short what? I am going to short only VSIG. So هخلي ال RS. Okay. So when I set VSIG to 0, بسمي for terminology resistance, I call it R out. When without RL. When I want to calculate RO, it is when Vn equals to what? To 0. So RO هي لما ال Vn equals to 0 and R out is when Vsig is equal to 0. هلا, this is just pure terminology. In reality, when we want to study a case, either we are going to say, I want to know for this amplifier what is its RO, okay, what is its RO, and in this aspect, this is the RO that goes into the amplifier model, okay, مع ال RN, or if I'm studying some time constant, then in that scenario, I'm going to set Vsig to 0. And in this case, what's going to happen when I'm setting Vsig to 0 for my time constant is أنا عندي capacitor هون. Really, the effective resistance seen will be what we called R out, يلي هي يعني Vsig equals 0 parallel ل RL, parallel resistance of the current source إذا كان هو some R. Okay, so the name R out is just for terminology. To say I'm looking at this amplifier and setting its Vsig to 0. Is this clear? Okay, so but you know which resistance what to set. If I'm calculating RO, I set Vn to 0 and Vn هي على طول على آخر ال Rsig. Okay, so if nobody has any questions, then I'm just going to proceed now with the slides, and so let us see what the next slide brings. Okay, so on this slide, okay, so he's trying to draw for me now the small signal model to do some derivations. So he's trying to draw for me the small signal model to do some derivations, and for this small signal model, I replaced the transistor with the pi model. So this is the pi model. يعني جيت قلت هيدي G, هيدي GMV GS. Okay, and this is my source node. Okay, and this is G, D, and S. And then I try to add the rest of the circuit. يعني at G I have DC in small signal analysis. At node S I have connected RS and VSIG, so might as well connect it here. Okay, and this is RS and VSIG. Okay, now I know that Vn is from the end of Rsig to ground, so it is between this node and this node here. So this is my Vn for the circuit, and the G is also grounded, so فعليا Vn is really between S and G. So the S هي ال positive node والG هي ال ground node. And then I have at the drain node connected, إذا اعتبرنا هيدا هو ideal, at the drain node I have my RL connected. Okay, so Vn is equal to what? It's equal to VSG. Okay, يعني if it is equal to GMVGS, I might as well say that this current is going up and is equal to GMVSG, okay, which is really GM times V. Okay, so طلع الكرنت. So I flipped the current because Vn equals VSG, and I made it as function of VSG اللي هي Vn. So practically speaking, and I don't need this G, no, it's already grounded. Okay, and really the circuit now looks something like this. So I have a resistor feeding a current source which is feeding an RL. So I can draw this equivalent circuit in a simplistic fashion now. which is something of this form. I have R sig, I have V sig, and this from here to here is Vn. This is what used to be node S. I have now the current source going from node S, feeding the load at node D. And this is our load. Node G is ground. خلاص, we don't worry about it. And this value is Gm times Vn. Okay, so this is my simplified circuit. We're putting it because you will automatically use now the circuits that result from this. يعني equations للgain والاquations للresistor. هلا we'll share them a little bit later. You can use them automatically. Okay, so let's see what the next slide tells us here. Okay, so let us go to the next slide. Okay, so this is the common gate amplifier. Let me flip to the iPad, the computer, because I fixed it and هون equations ما بيطلع منه. Okay, so let me stop sharing. Sorry for the inconvenience. Okay. Okay. Okay, so let me share the screen again from here. Okay, so now we will see the equations of the derivation تاعت the common gate amplifier. Okay, so let us see the common gate amplifier. And now we said that, sorry, this is هيدا عم نطلع قلنا إنه VGS is equal to Vn minus Vn, and accordingly we said that I can now flip the current source بصير طالع طلوع بصير GmVn, and this is the effective model for it. So for the effective model for this amplifier, In is coming into Vn, okay? So I can easily express my Rn. It is Vn over In, but what is In? It is GmVn. Okay, so دغري طلع معنا الانبوت resistor هو 1 على GM. Okay, so if we look how we are looking into this, I have the transistor with some load at this node. Okay, and I have the gate is grounded, and for Rn, Vs is Vn, right? So I'm looking here and I'm saying what is Rn, and I'm saying that this Rn is equal to 1 over Gm of the transistor. So if you look at the resistor sheet, and I'm taking you to the resistor sheet for you to know what you can use. If we look at the resistor sheet, okay, and we go to the rule, and I will count the rules with you for you to feel comfortable with that. Okay, rule number 8 says that, well, if I'm looking into the source of the transistor with some resistance RD, هون عنا RL, at the drain, and with the gate grounded, I don't have RO. If lambda equals to 0, R is 1 over Gm of this transistor. And if lambda is different from 0, يعني if I have RO, it's going to be RD plus RO over 1 plus GM RO. And if you set, okay, and if for other application RD is 0, we have some specific equation. Okay, فإذا in this scenario here, it is telling me that here is your Rn that you're going to see. يعني أنا if I give you now a common source, a common gate amplifier, pardon me, with some V sig R sig, okay, and I tell you that this transistor has some RD here or R load here at this node, and this is our Vn because Vn is at the end of R sig, and I tell you what is the input resistance, automatically you will take this rule and say, if I have RO, I will be relying on RO, RD, and GM. If not, it is 1 over GM. Okay, so Rn is 1 over GM, which is what we just proved in the small signal analysis of this circuit. Too many rules? No. Let us try to simplify it in our mind, because now we almost saw all of them. For the MOSFET, I have 4 sets of rules that we have seen so far. The first one is that the input to the gate, independent of what is connected to the drain and source. يعني هو MOSFET has 3 nodes. So I can look at it from 3 locations. So looking into the gate, R is infinity. We know this. Looking into the drain with this grounded and this grounded, I will see RO. هيدي تاني rule تعلمناها عن MOSFET so far. And then looking into the drain with this grounded and with some resistance at the source, I see RXY. Okay, this rule we're gonna learn it later, and this is the third rule, which is now, okay, the third node is the source, and I'm looking up the source with the gate grounded and some resistance at node D. Here's the equation for it. Okay, is this clear? فإذا في عنا 3 or 2 non-trivial rules اللي هي لما بكون عندي ال RXY ولما عم بطلع من ال RS، الباقيين هينين يا infinity يا RO. Okay, anybody has any questions about the resistor sheet? طب, if nobody has questions about the resistor sheet, let me go back to the slides. Okay, now we're going to go back to the derivation, but you can use the resistor sheet, you can use the rules as you see suitable. So here it is telling me that the pi model will give me that Rn is 1 over Gm. Okay, and let us see what is the next thing that we derive. For this specific circuit, he's showing me the main features of this design. Because some amplifiers, we can model them as a voltage amplifier. Okay, so visual amplifier or voltage amplifier هيدي Rn. I can also model it as a current amplifier. Okay, in parallel مع عندي R O لإلها، وعندها هون هي ال current source عنده parallel لإله its own Rn. صح؟ So إذا ال current source عنده its own resistance، إذا ال current source عنده signal، عنده كمان هون حيكون its own Rn. Okay, so let us now see what are the features or characteristics of this amplifier. If I want to look at the current gain, where is I out? And this is important for you to know, and you'll see many questions pop up as what is IO over I out, or I know that IO over IN هالقد. وين ال I out؟ وين بتمشي ال I out؟ in R load. I out flows, IO flows in the load, صح؟ So what is IO على IN? What is IO على IN? 0. What is IO على IN? Who knows?
1.
1. So IO على IN is 1. Therefore, the current gain of this circuit is what? AI equals to 1. يعني this circuit acts as a current buffer. Sometimes I don't want gain, but I want to shield my circuit with good input resistance. لنفترض أنا عندي circuit تاني whose Rn. Let me ask you this question. If I have a signal, okay, and a signal has its own Rsig, let us say which is 10K, and then the Rn for my amplifier is مثلا 100K. What is going to happen to the signal Isig? شو حيصير فيها? In what resistance is it going to flow?
بال 10K.
It will flow in the 10K. So فعليا if I am amplifying IN, okay, if I am amplifying IN, the signal it will absorb most. حتبعت للسيركت كتير قليل. It will absorb its own signal resistance, صح؟ طيب, if I now design another amplifier whose Rn is small, okay, whose Rn is small, يعني هيدي sorry بعدها 10K, بس let us say that my Rn is 600 ohm. وين حتروح معظم الIsig? To Rn, right?
على Rn.
Okay, so Rn لهيدا السيركت لأنه من على GM it is very small, and so it has a small input resistance, It does not amplify well, but it can shield me from a supply whose signal resistance is high. يعني بستعمله كبفر ستيج لحتى اسحب to absorb most of the signal from input signal اللي عندي على RN اللي لإلي, and then I feed it to another amplifier who's going to amplify it. So these are the little tricks that can be used. هلا for you, what you need to know from this circuit, لكن it has a small RN, it has a current gain which is equal to 1. And what is the voltage gain? How do I derive the voltage gain? هي IN is continuing here. So VO is RL times IN. And Vn, I know what it is. So I can find the gain. So let us see what is Vn. شو هي Vn in terms of IN? هي IN ضرب Rn, which I already computed, صح? Okay. So I have the Vn, actually I have GMVN, sorry, I have the relation GMVN already from, what is II? ما هي VO هي RL ضرب II. What is VO? يعني RL times GM ضرب VN. So VO على VN is equal to what? GMRL. هلا إذا بتلاحظوا, what is the gain? Positive. يعني أنا لما كان عندي الاوتبوت على الدرين, هيدي important بعدين للفيدباك, هيدا الRL, وبعثت له الانبوت من الجيت والسيجنال كان source كان grounded, طلع الجين minus GMRL إذا ما عندي RO, إذا RO is infinite, صح؟ طيب when I flip this, when I apply the signal from the source, when I apply the signal from the source, افترضوا ما عندي RS, دغري حطيت هون some VN, وهيدي is grounded, شو طلع الجين؟ طلع plus GMRL. فإذا the gain from the gate to the drain was negative, but from the source to the drain is positive. Okay, هيدي very important later for the feedback to note إنه هي positive مش negative. Please انتبهوا for your answers, be careful about it. طيب هلا so the voltage gain لكان هو GMRL, and can I know what is VO على Vsig? Can I know what is VO على Vsig? It is equal ل VO على Vn ضرب Vn على Vsig. هيدي معي, do I know what Vn على Vsig is? And this is something also very, very important for you to know and remember for all types of amplifiers. What is Vn over Vsig? What is the resistance that I see here?
Rn over Rn plus Rs.
Exactly. So this is Rn over Rn plus R6. So أنتوا إذا عندكم الexpression للRn, you can automatically very easily find the overall gain. Okay? يعني this trick from the input side and another trick at the output side, they are always used in the problem. So انتبهوا لها. So هلا لكينا صرت بعرف التوتال gain. Now what is the output resistance? نحن طلعنا ال output resistance, صح? We already found what the output resistance is from the resistor sheet. Okay, so no need, I will go over it very quickly for the output resistance. هلا in this circuit, output resistance is when I set Vn to 0, صح? And I remove RL and I look from here. Vn 0 صار هيدا الكارنت شو؟ 0. Okay, صار open circuit, صارت it's going to tend to infinity. نحن already قلنا إنه RO is equal to little RO, so when lambda equals 0, it's going to tend to infinity, حسب what we derived. Okay, and so this circuit is characterized لكينا by small input resistance. The output resistance is very large, it is infinite. So if I have a current amplifier with output resistance infinite, it's perfect and it's going to deliver all the current where? To the load. Okay, so it acts as a perfect buffer لأن عندها small Rn و large Ro. And it has a unity current gain. It has a positive, إذا اعتمدته كvoltage amplifier عنده positive voltage gain. Okay, whole characteristics which we saw so far. طب هلا the input resistance already مرقنا على الشيت قلنا هو 1 على جي ام، وهيدا عم بيعد لي الرول ليقول لي انه looking up from here if I have RD. Okay, I have two cases. One case which is it is equal to 1 over gm إذا RO is infinite, else it's equal إن RD على RO على 1 plus gm RO. هيدي بتطلع من rule which we just saw. And let me double check the equation حتى ما أكون حافظ الغلط. Let me share with you the equation for okay لا مظبوط. Okay, so looking into here we have those two possible resistances as the input resistance, وهيدي الرule you can use it from here on. Okay, so هلا عم يعمل لي derivation للكيس انه when I have RO كيف طلعت معه equation. Okay, so we don't have to go through it, but the basic gist of it انه انا بعرف انه IN is equal to GMVN plus VN minus VO. هي هو two currents على RO. وأنا I know that what VN is. Okay, so what VO is as function of IN. Okay, so I can take this expression and plug it in here. And therefore I will have an equation that relates IN to VN وبقدر طلع لها الcomplex resistance يلي هي تطلع equation يلي نحن we just derived. فإذا نعتمد على VO equal RL لأنه هي IN عم تفرق هون عم ترجع تجمع هون، يعني بعده VO equal RL times IN. Okay, this is the important thing that you need to know, and you can use this equation as is. Okay, حدا عنده أسئلة على ليش VO equal RL ضرب IN؟ طيب great. Okay, so this is I find the Rn in general. and هلا terminology بس لأنه because ما هي قلنا RO plus RD على 1 plus GM RO, because RD in this example was nothing but my RL. So because in this scenario I can see from the input pin اللي هو هون load حنسميها RN تنبه to caution ourselves إنه this input sees the output لأنه typically when I'm looking from the gate I am shielded what is the load. I don't see it. Here I don't see RL, but here in this scenario I see RL from the input لأنه it is joined by RO. Okay, so this is just terminology and notification for us. Okay, so this is the equation from the resistor sheet. هلا إذا بدنا نطلع على هيدا السيركت ونشوف what is the open circuit voltage gain, we can here say, well, I don't have R load, so what this means that I is equal to 0, IN equals 0. So this means that VN minus VO على RO is going to be equal to GMVN لأنه هيدا الcurrent is going to flip back in this loop. هلا this is very theoretical. Okay, so from this I can find a relation between VO VN, and I can say that the gain is equal to 1 plus GM RO. So for this circuit, VO over VN when RL tends to infinity is equal to 1 plus GM times RO. Okay, so this is the open circuit voltage gain. Why do they teach us the open circuit voltage gain? And next time we look at the gain sheet, لأنه أنا when I draw this circuit, I'm going to draw it like this. And I'm going to have Rn here, okay? And now anytime I have a load resistance, I'm going to put the load across my output here. So هحط ال R load home. So this is going to be my R load across this node here. Great, okay? So if I have AVO times VN, okay, and I know my RO, what is the VO over VN in the presence of RL? What is it equal to? How do I find it? VO is equal to what? AVO times VN times what? RL over RL plus RO صح؟ So AVO على VN VO على VN حتكون AVO ضرب RL على RL plus RO. أنا I know what my AVO is, so I can plug it here. And I have already derived the RO for this circuit, right? So I can, if I have RL, I can find the gain. يعني the problems that you will see will vary between I know AV, find RO, and vice versa. يعني if I have this and this, okay, and I have this, you can find this and vice versa. So هيدي relation بين ال RN وال RSig وال VN على VSig, be careful about it. And the relation between AVO and AV, okay, اللي هي إنه AV is equal to AVO times RL على RL plus RO for the circuit. كمان نويت لأنه one of these will be known and the other one of them will be variable. Some of these will be known and the other will be variable. هلا next time we will go over this slide again, but these are important things that you need to keep